Hello and welcome to part 2 of this video where we're looking at the GCSE exam paper from Pearson Edexcel. This is the November 2018 series and it's paper 1, non-calculator. We're up to question number 11. Let's begin. Here are some fractions. One of these fractions is not equivalent to 3/4. Which fraction? So in order to determine which one of these fractions is not equivalent to 3/4, we're going to simplify these fractions to find out which one does not become 3/4 once we are done. So to begin with, 9 over 12, well 9 and 12 can both be divided by 3. 9 divided by 3 is 3 and 12 divided by 3 is 4. So that fraction is equivalent to 3/4. 6 and 8 can both be divided by 2. So that's 3 and 4. 18 and 24 can both be divided by 6. So far all of these fractions have been equivalent to 3/4. 10 over 16, they can both be divided by 2, which gives us 5 over 8, and that fraction can't be simplified any further, therefore it is not equivalent to 3/4, so 10 over 16 is going to be our answer. Just to show you the last one works, 15 and 20 can both be divided by 5, which will also give us 3/4. Part B. Work out 1/12 plus 5/6. In order to add or subtract fractions, the denominators, the bottom numbers, need to be equal to each other. Now this can be any common multiple, so for example we could use 24, we could use 72, those are common multiples of 12 and 6. I'm going to choose to use the lowest common multiple, and the lowest common multiple, which is the number that appears in both times tables of these, is 12. So 1 over 12 actually doesn't need to change in this case, but the 5 over 6, we need to turn that 6 into a 12. Well, to turn 6 into 12 we need to multiply it by 2, and if we multiply the 6 by 2 to get 12, we also need to multiply the 5 by 2 to get 10. Once those fractions have the same denominator, a common denominator, we can just add the numerators, the top numbers together. So 1 plus 10 is 11, and the bottom number of the fraction does not change. So 1/12 plus 5/6 is 11/12. Question 12. Tom uses his lorry to deliver bricks. You can use this graph to find the delivery cost for different distances. For each delivery there is a fixed charge plus a charge for the distance. How much is the fixed charge? Now a fixed charge is where you are charged something without anything having changed in terms of distance. So on here, if we're travelling no miles, we are still being charged £10 because that is directly in the middle of 0 and 20. So in this case the fixed charge is £10. Tom makes 2 deliveries of bricks. The distance of one delivery is 20 miles more than the distance of the other delivery. Work out the difference between the 2 delivery costs. So we need to work out 2 different costs for 2 different distances where those distances are 20 miles apart. Now you can do that anywhere on the scale. I'm going to choose some easier numbers, so I'm going to use 20 miles. Now to work out the cost for that, I'm going to draw a line up from 20 until it reaches this diagonal, and then read across to find the delivery cost. So for 20 miles the delivery cost is £40. Now we need another distance that's 20 miles more than that. So 20 miles above 20 is 40. And once again I'm going to repeat that up to the line and read across. We have landed halfway between 60 and 80, that is going to be £70. And so to work out the difference between the 2 delivery costs, we're going to subtract those numbers from one another. £70 minus £40 means that the difference is £30. Question 13. Asmal, Ryan and Kim each played a game. Asmal's score was 4 times Ryan's score. Kim's score was half of Asmal's score. Write down the ratio of Asmal's score to Ryan's score to Kim's score. So we've got three people. We've got Asmal, we've got Ryan, and we've got Kim. And we're told the relationship between those scores. So if we were starting with Ryan's score, in order to turn that into Asmal's score, we know that Asmal's score is 4 times that of Ryan's. So we would take Ryan's score, multiply it by 4, and that would give us Asmal's score. In order to get Kim's score, we know that Kim's score is half of Asmal's score. So we'd start with Asmal's score, and to get it over to Kim's score, that would mean we would have to half it, which is dividing by 2. The only thing we need to do now to find the ratio is just to substitute any number into this situation. So you can give Ryan any number of marks for his score. I'm going to give him just the number 1. So if Ryan scores 1, Asmal will score 4 times that. 4 times 1 means Asmal will score 4. And Kim has half of Asmal's score, so 4 divided by 2 is 2. So if Ryan scored 1, Asmal would score 4, Kim would score 2, and we just write that as a ratio. Question 14. The diagram shows quadrilateral ABCD with each of its sides extended. AB equals AD. We can see that from the 2 dashes on those 2 lines. Show that ABCD is a kite. Give a reason for each stage of your working. Now, before we begin with the angles, let's just see what we're trying to end up with. We're trying to show that ABCD is a kite. Now, a kite has 2 shorter sides at the top and then 2 longer sides at the bottom. So those 2 sides are the same as each other, and those 2 sides will be the same as each other. In addition to that, this angle on the left here is also equal to this angle on the right here. So we're trying to show that this shape falls into this category. Now, in order to make these things look similar, I'm going to take that, apologies, technical issues, I'm going to take this and rotate it. So that's what we're looking at. We're looking at those 2 sides at the bottom being equal, so that's these 2 sides here, which means that we actually need to show that these 2 angles, which means these 2 angles here, are equal to each other. And that will be enough to prove that this is a kite. So, let's start here. We've got an angle of 75 degrees. There is a fact that we need to use, and that is that angles on a straight line add to 180, which means that if this angle is 75, this angle here must be 105, so that the 2 numbers add up to 180. This is what it means by giving a reason for each stage of your working. In the Edexcel exam papers, these words that I have underlined must be present in your reason, otherwise the mark is not awarded. So we've got one angle. The next angle we know is this angle up here, and for that we need another fact. That one is that vertically opposite angles are equal. So if this angle here is 50, this angle here is also 50 degrees. The last fact, in order for us to work out what this angle is here, is that angles in a quadrilateral add to 360. So we've already got 100, 105 and 50. If we add them together, so 100 plus 105 plus 50, we get 255. The angles in a quadrilateral always have to add up to 360, so we can do 360 and subtract that 255 to say that that angle is 105 degrees. And we have done it. we have shown that this is a kite because we have those two sides which we are told are equal, and these two angles opposite from one another are both 105 degrees. Question 15. Shahid is going to use these instructions to make a fizzy drink. Mix 5 parts of orange juice with 2 parts of lemonade. Shahid thinks that he has 300 millilitres of orange juice and 200 millilitres of lemonade. If Shahid is correct, what is the greatest amount of fizzy drink he can make? Now, whenever we're told how many parts of two different things that we've got, or even more than two things, I tend to draw a bar model. So the bar model for this particular question would look like this. So we've got orange juice with its 5 parts and lemonade with its 2 parts. Now, usually when you have a question like this, you are only told one quantity, one amount. Since we are told 2 different amounts, so an amount for orange juice and an amount for lemonade, that means we actually have to do this question twice and use one number in each part. So, to begin with, Shahid thinks he has 300 millilitres of orange juice. So that means that the orange juice, these 5 parts, would have to total 300. If we know that, we can work out what just one of these parts is by dividing 300 by 5. 300 divided by 5 is 60. So each part is worth 60, and that is also true for the lemonade in this particular part. So that means if we are using all 300 millilitres of orange juice, we will have a total of 120 millilitres of lemonade. Now we move on to the second part of the question. We've already used the 300 millilitres of orange juice, so we're going to discount that this time and say that we have 200 millilitres of lemonade. So if 200 millilitres is the total for lemonade, each of these parts will be half of 200, which means they will each be worth 100. Once again, that is going to be the case for every part of this. So if we are using 200 millilitres of lemonade, we'll be using a total of 500 millilitres of orange juice. And the reason they give 2 numbers is because you can now see that this scenario is impossible. We can't use all 200 millilitres of lemonade because that would mean that we would need 500 millilitres of orange juice, but we only have 300. So this can be discounted, which means that this is what we're going to use to answer our question. So what is the greatest amount of fizzy drink he can make? Well, the fizzy drink is all of this put together. So he'll be using 300 millilitres of orange juice, 120 millilitres of lemonade, which means he'll make a total of 420 millilitres of fizzy drink. Part B. Shahid has 300 millilitres of orange juice, but he only has 160 millilitres of lemonade. Does this affect the greatest amount of fizzy drink that he can make? Give a reason for your answer. Now, we don't actually need to do any calculation for this. From our previous working, we can see that if he uses all 300 millilitres of orange juice, he's only using 120 millilitres of lemonade. Since he has 160 millilitres, he will be using 120 of that, which means that no, it is not going to change the amount. It's still going to be using 300 millilitres of orange juice and 120 millilitres of lemonade. Question 16. Here are 2 rectangles. Jim says the 2 rectangles are similar because 8 plus 4 equals 12 and 6 plus 4 equals 10. Is Jim correct? Explain your answer. Now, when you are saying 2 shapes are similar, that means that one shape is an enlargement of another. When you are enlarging a shape, you are using something called a scale factor. Now, a scale factor is a number that you will multiply a distance by to get a new distance. Note the word multiply. In Jim's situation, he's adding 4, which means that this would not be a similarity situation. However, there are certain circumstances where that would work, but that's just a coincidence. Just to prove this on this question, we can work out the scale factor going from 8 to 12. So to work out a scale factor, which I'm going to abbreviate to SF, to work out a scale factor, you take the original image and the new image and divide them. So you will divide the new distance, which in this case is going to be 12, and you divide that by the original distance, which is 8, and 12 divided by 8 is 1.5. That's the scale factor. That means that each of these sides should be 1.5 times the original distance. If you apply that to the other side of 6, 6 lots of 1.5 is 9. Which means that if this 10 centimetres was 9 centimetres instead, then it would have been similar. But since it's 10, it is not. So no, this is not a similarity situation because he's added 4 instead of multiplying the two numbers. Question 17. 80 people are asked if they like coffee. 48 of these people are women. 61 of the 80 people like coffee. 8 of the men do not like coffee. Use this information to complete the frequency tree. So there's some parts of this information we can plot instantly. So we have got 80 people, which are already shown. 48 of these people are women. So if we go down the women route, we will have 48 of them. Now, we can't use the 61 of the 80 people who like coffee at the moment. That would be this top circle here, this top oval, and this third one here. We don't know how that 61 is split between them, so we're going to have to come back to that piece of information. We do, however, know that 8 of the men do not like coffee. So if we go up the men route, and then to do not like coffee, we know that has to be an 8. We can now start working out other numbers. If we know there are 48 women, then we can work out the number of men by doing 80 minus 48 to give us 32. So there are 32 men. If we know that of those 32 men, 8 of them do not like coffee, we can work out the amount that do like coffee by doing 32 minus 8 to give us 24. Now that we know an amount of people who like coffee, we can go back to that original piece of information that 61 people like coffee in total. So we can do 61 minus that 24 to tell us that 37 of the women like coffee. And to finish this off, how many women do not like coffee? 48 women total, 37 like coffee, meaning 11 do not like coffee. One of the people who like coffee is chosen at random. Find the probability that this person is a woman. Now this is where people need to be very careful and read the question. Who are we choosing from? Are we choosing from the entire number of people? Are we choosing from the men? Are we choosing from the women? This can change from question to question. In this case, we are choosing from the people who like coffee. How many people like coffee? Well, we're told in the original part of the question that 61 people like coffee. That means that our probability is going to be out of 61 people. How many of those people are women? Well, women who like coffee totals 37. So 37 out of the 61 people are women who like coffee. So there is our probability. And question 18, going to be the last question of this part. Food Mart and Jan's store sell boxes of the same type of breakfast cereal. Each shop has a special offer. So at Food Mart you get 400 grams with 20% off the normal price of £5. At Jan Store, you're getting a 400 grams plus an extra 30% for £5. Which box of cereal is the better value for money? You must show you're working. So first of all, let's work out how much cereal we are getting and how much it costs at each of the two stores. So starting with Food Mart, we're getting 400 grams, but we're getting 20% off the price of £5. So finding 20% of £5, 100% is £5. 10% would be where you divide that number by 10, which would be 50 pence. Which means that 20% will be double the amount of 10%. 20 is double 10, so doubling 50p gives us £1. We are getting £1 off the price of the cereal, so we're getting £1 off £5, which means that we're going to be getting 400 grams for £4. Over at Jan Store, we're getting 400 grams plus an extra 30%. So 100% is 400 grams. Following the same method, finding 10% means you are dividing by 10. So 400 divided by 10 is 40 grams. And 30% means we are timesing 10% by 3. So 40 grams times 3 is 120 grams. So in total, at Jan Store, we're getting the 400 gram box plus 30% extra, so we're getting 520 grams, and that's costing £5. We now need to be able to compare these two offers. Now we can do that in a few different ways. We could either scale both of these amounts up so that we get the same amount of cereal, so trying to find a way of turning the number 400 and 520 into the same amount, and then check out the prices and see which one gives you the better value. Or you can work out a common price, so turning the £4 and £5 into the same number and then comparing how much cereal we get. That's the version I'm going to choose. Now you can do that once again in two different ways. You can either scale both of these down to work out how much you get for £1, or you could scale them both up to a common multiple. So for example, we could choose £20 and see how much cereal we get for £20 each. I'm going to choose £1 because I think it'll be an easier calculation. So to turn £4 into £1, we are dividing by 4. So 400 grams divided by 4 means that we will be getting 100 grams for £1. Over at Jan Store, to get from £5 down to £1, we are dividing by 5. And 520 divided by 5 is 104. So which one gives us the better value for money? Well, at Food Mart you're only getting 100 grams for £1, whereas at Jan Store you're getting 104 grams for £1. You are getting more cereal for the same amount of money at Jan Store. That's the end of this part of the video. We'll have a look at question 19 and beyond in the next part.